morning, everyone. If anyone's here already, just getting the stream started again. Yeah, we've already got a first post in chat. Hello, good morning. Cool. So, let's get back to some context here. Where's my context? Of course, my context doesn't have keyboard focus. But Tuco's standing on that stair thing, which is pretty cool. Let's take a closer look at that first. This little bit of furniture is actually being used as it's intended. It's kind of a cat stair that a friend of mine designed for his cat who recently passed away. And so he brought it over in the hopes that Tuco might like it. And in fact, Tuco does seem to really like it. So I just need to figure out where to mount it on the wall to give him good access to something new. But for now, he's just been hanging out on it. All right, so what else have we got going? Don't want to lose track of Tuco, but we can keep him in a little window. So, hello, this is me. My coffee is empty. I might make more soon. And let's wake up the camera. So I did a stream, I guess in my time zone it went pretty late last night. Oops, that's not the right button. And it was something that I hadn't actually streamed about before. It's kind of a new project that I've been working on that's kind of related to a thing that I published in my most recent kind of long Scanlime blog video. This was a glitching setup that I was using to get firmware out of a USB device through its USB interface by kind of using an electrical glitch to cause the USB enumeration code to malfunction in a way that would return the firmware instead of the USB descriptor. So in this case, I'm trying to do something similar, but with Ethernet in place of USB. And so I went into some of the setup for this last night. But just to briefly recap here, there's a, make sure I'm focused. Just to briefly recap here, there's a development board here with a microcontroller that I'm actually trying to target. So that microcontroller has a built-in Ethernet interface that does 10 base T or 100 base T. It can run at 120 megahertz, which is its usual speed. Hey boy. And so here I've modified it to take an external clock, and I've got some SMA connectors for monitoring and glitching power. And I'm using this chip whisperer board over here, which is the same board that I used to coordinate the glitching on the other processor I was working on, the USB microcontroller. And then down here I have a little FPGA, which is just running a really tiny bit of logic that just does some clock synthesis so that I can have a clock on the chip whisperer which should match the clock which the microcontroller then internally synthesizes for its own operation. So this FPGA is kind of doing the inverse of the clock synthesis in this chip in order to have the chip whisperer and the internal core running on close to the same clock. And then back here is an Ethernet interface. It's a little 10 base T to SPI Joby from Microchip called the ENC28J60. And it's just acting as a second Ethernet interface on this Raspberry Pi here. But the reason I use that particular board is that I can underclock it and then still have it interface to the outside world over this externally clocked SPI interface. So I have both of these Ethernet interfaces underclocked at the same rate. So that's pretty much the setup. The place we had gotten to last night on this was I had most of the setup pretty well verified. Like, I was pretty happy with it, and I was trying to get from just having a reproducible way of underclocking the microcontroller and sending it a web request, so sending it like an HTTP GET that I can try to glitch, and then triggering my timing. So all of that is set up in this test, but the actual glitch pulses weren't doing anything, and it turns out that I think that's just, my hunch was that it was just all the little electrical kind of imperfections in the circuit, so propagation across this cable where I was originally sending the glitch pulse, and then just the capacitance of the gate in the MOSFET, it not switching on as fast as it could. So here I'm going to try to solve that problem by changing the glitching setup slightly. instead of having a transistor over here, which is pulsed directly by the FPGA, and then pulls the core voltage down through a long piece of coax cable, instead of that, I'm going to try putting the MOSFET really close to the chip here. Also having a buffer close to the chip, and ideally this would be a purpose-designed MOSFET gate driver chip, something that's designed for that really high instantaneous current pulse. I don't think I have any of those handy. I might check really quickly, but I think my plan is to see if I can use kind of a general purpose, but still pretty fast, not hex, but an inverting Schmidt trigger buffer. And so this is just a logic gate that's designed specifically to tolerate having kind of messy analog signals coming into it and to use some hysteresis to cleanly switch on and off. So that combined with a pretty fast output edge rate, so it'll actually rise and fall quickly, plus a capacity to drive a decent amount of current. That's what I'm really looking for here. So, like, I don't need like something amazingly huge, because it's not like I'm building like a really huge switching power supply or something where the edge rate really determines how much heat is going into my MOSFET. But I do need something that can actually overpower the low dropout regulator that's built into this microcontroller, which is what this MOSFET is kind of pulling against. So to get the transistor and a small buffer on here, I could just solder them directly, but this seems like a good use for a small circuit board and something that I'd probably reuse later. So I was just going to do a really quick design in, I hadn't quite decided on Eagle or KiCad for this. I think I might go for KiCad just because I like KiCad and I like to use it as kind of an open source alternative as much as I can. And I might even already have some of the parts for this modeled in KiCad, because part of the reason I have parts in stock is usually because I got them for a different project, and so I can pull up the schematics for that project. So let's first maybe take a look at the actual parts that we're talking about here. Get a better idea of what the electrical values involved are. We just want that view. All right, so I have these parts over here. Oh, and while I get this sorted out, there's actually a pretty good another good kind of context question in chat. What is a glitch and why does it need buffering? Which is great. So in this case, a glitch is actually, another name for this would be a fault that I'm trying to inject. So in this processor, so this chip that I'm centering right now is a microcontroller that I want to intentionally and very precisely cause to malfunction, so that it, instead of doing what it's supposed to, gives me a copy of its code. So one way that I can do that is by rapidly changing the power supply voltage that the chip sees. So, for example, if you imagine turning off the power like right in the middle of an operation such that the operation doesn't fully complete. That's the kind of behavior I'm looking for. And it might not really be like turning off the chip. It might be kind of causing spurious clocks or causing memory reads or writes to fail. There are a lot of actual internal mechanisms that could be responsible for the different behavior. But really, this is just kind of a way of causing like very localized chaos in the chip in order to cause some bit flips to cause the behavior to be different than it otherwise would be. So that connector that's currently open on the right is where I had this cable running to this other open SMA connector. And that's the board that was actually generating this glitch by just using a transistor to kind of yank the power supply to ground momentarily. Let's take this probe off. So yeah, that little 8-pin device right below the screw is a transistor, so that's a MOSFET. And that's what's doing its best to kind of drain all the power out of this microcontroller's core voltage rail, but both because of the resistances and presumably the kind of transmission line delay of the kind of negative current pulse here. Like, it's not really winning against the regulator. So we were looking at those, we were looking at the gate driving the MOSFET versus the actual core voltage last night. And it was having an effect, but not very much of one. Like, it wasn't getting the voltage even down to like half of what it usually is, and the intention here is to briefly pull it down all the way to 0. So that's why my idea is to, I think the buffer serves a couple of purposes. One is that I want to clean up the kind of messy signal that I've got over here, because the output from the Chip Whisperer's FPGA is already driving that existing transistor, which has some capacitance to it, and that's giving me kind of a messy edge. So I might end up even needing to put a buffer like right over here on this board, just to have something close by, or I might even need to end up removing that MOSFET or even using a different output on the FPGA. But the easiest thing, and the thing that I think is worth trying first, is to leave the Chip Whisperer unmodified and just run some more jumper wires from the input of that MOSFET and kind of ignore the MOSFET itself and its output. And then closer to here, so on something that I can just like glue to this board, have a little circuit that that kind of cleans up that that kind of triangle-looking signal that we have going into the MOSFET gate and gives us more square wave edges. That's what the Schmidt trigger buffer will do. And then another function of the buffer, and so maybe a different buffer, because maybe I want to run this on a higher voltage, would be to actually supply the current that goes into charging the gate capacitance in the MOSFET. Because if you're not familiar with how MOSFET transistors operate, instead of kind of traditional, so transistors that aren't MOSFETs are usually BJTs or bipolar junction transistors. If you see just like a normal like NPN or PNP transistor, that's what that is. And so those act as current amplifiers. You give it a small current and then some factor of 100 or a couple dozen or whatever, and it multiplies that and gives you a larger current, very, very roughly. But a MOSFET is basically a kind of voltage to resistance converter. It has a gate which is sensitive to voltage but doesn't actually draw current. It acts more like a capacitor. So it takes current to change the gate voltage, but if you just leave the gate at a particular voltage, then it doesn't draw any current, except for tiny amounts of leakage. So based on that, the voltage across the gate, the MOSFET goes from having an effectively infinite resistance to a very close to 0 resistance, which is why they can end up working much more efficiently for switching than a bipolar junction transistor, which can never really go entirely to 0 voltage drop. So anyway, that was a tangent. But tangents are great. Just catching up on chat briefly. Talking about the transmission line. Yeah, I'm not sure whether we're talking about the signal going into the MOSFET gate or whether we're talking about the actual power rails. The MOSFET gate signal, yeah, it seems pretty straightforward, and I'm going to just see if I can clean it up with a buffer on this end of the cable. But then the actual core voltage, I'm still not entirely sure how hard it's going to be to actually pull that all the way to 0 through the LDO. And so I don't know how much, what the effective internal impedance of the LDO's output looks like. I do have an ohm of resistance, which is about as much as I could get away with on the 3.3 volt rail. Yeah, it's under the scope probe, but there's a giant resistor there, which is my 1 ohm, because I didn't have any surface mount 1 ohms at the time. So yeah, I'm just going to stick something near here and see if I can get a good signal. And so I have some parts handy that should work for that. So I actually ordered these MOSFETs specifically for this glitching project. And these just happen to be the same ones that the Chip Whisperer has on board. So I just didn't want to have too many more variables, so I wanted to have a transistor that was as close as possible to what I was already dealing with. And so you can see this is actually rated for 8.3 amps. It's designed for a lot of continuous current. But in this case, what we really want is that low on resistance, and that's the same quality that would give it that kind of high continuous current rating. But in this case, we just want that so we can have a really low impedance connection to ground and just discharge that circuit as much as possible. The downside of this being such a large MOSFET is that it is kind of slow, which it means that because it's physically large, the gate acts like a larger capacitor, and you need more current to charge it. So for that, that's what we need a buffer for. And there are chips specifically designed for this purpose, so MOSFET gate drivers. And if I was going to place an order for this, I would get one of those. And in fact, we might just look at DigiKey really quick just to see how those compare to this buffer, to see if this is even worth trying. Because if this isn't even going to work, then like I could order a buffer from DigiKey and put this off for a few days. But I think this will be fine. Because if I remember right, when I got these inverter buffers, you know, I got them for something where I was like using them to drive coils in a power supply, and so I needed them to be somewhat high current, and so I think these are spec'd to drive like 30 milliamps, which is nothing for like instantaneous current on a MOSFET driver, but as far as like continuous current rating compared to what this FPGA is rated at, like it'll be a big improvement over this, so it seems worth a try. And then because it's a Schmidt trigger, it'll give us that kind of cleanup, kind of taking the ramp up and turning it into a smooth, or like a nice sharp transition. Might end up needing to use 2 of these though, because what I might want to do is use a 3.3 volt power supply for the first buffer, so that I have a good reference logic level for recovering the signal coming from the FPGA. But then use another buffer running at 5 volts just to have a higher drive level for the MOSFET to give it a faster turn on. So these, let's see, did we get the part numbers here? So this MOSFET, I just want to make sure I read that off. So that's an, yeah, IRF 7807. It's weird, you'd think it would be easy to read on the screen, but even though this camera is recording in nice like 1080p, the HDMI output is super low quality. And then the buffers I'm using, these are actually kind of cute. They're a little bit tiny. This might be an interesting kind of little tidbit for the PCB assembly video that I'm also working on, because they, like I think this is the largest package you can get this part in. It's an SC70-6, which if you're familiar with like an SOT, like an SOT 23 or those little like 3-pin packages. So an SO23-6 or whatever with 6 pins. It's a lot like that. It looks very, very similar, but it's like half the size. And then you can also get these in, I think, some kind of VGA and WLCS, you know, whatever the wafer level chip scale packages are. So things where they basically just take a raw die and then just flip it over and make it plated enough that you can bond it. So we'll take a look at the data sheet for that. Let's go back to the computer. Alright, NC7WZ 14P6X is this thing. Oh man. I think I'm just going to get the data sheet from DigiKey, because the Google results are a little polluted. It's also, I mean, I could get this from the manufacturer. I think it's National Semiconductor. Oh, Fairchild. Alright, well, so it's useful to look at these on DigiKey anyway. So I got a bunch of these for, partly because they're handy to have around as like just little bits of logic, and partly for this project I was working on a while ago called Wiggleport, which isn't dead, just kind of on the back burner for a while. Whoops, got my mouse stuck again. Bear with me. I keep hitting this bug where if I have the screen zoomed and then I use Synergy to move my mouse to the other computer, then it gets stuck, because I think Synergy forgets how to change the mouse position on its own. So anyway, the important thing about these, they're Schmidt trigger, they've got a pretty nice wide voltage range, so I can use the same chip at both 3.3 and 5 volts, and they can drive 32 milliamps, which is pretty high for a logic gate. Oh yeah. So somebody in the chat, Tim Williams, has been doing the math, which I'm too distracted / lazy to do, and saying that in order to do it in a few tens of nanoseconds, I'm going to need about an amp of peak current, which is probably more than this can handle. Like, that sounds like I might need a dedicated MOSFET driver. And, you know, there might be other things I have in the shop, like motor drivers that can do that, but I don't know if they'd be fast enough. Let's see if this has any good AC charts. Yeah, these propagation delays don't help a whole lot. So we can really just see the difference between, well, what is it like driving a mega ohm versus 500 ohms, which are both a good bit more impedance than we're actually going to be seeing here. So, yeah, it might be that what I want to do is get a real MOSFET driver. And we can take a look at those quickly on DigiKey. I'm probably going to go ahead and make a board using this for now, just because it's probably going to work well enough to at least help me make progress. But let's just keep that open and also take a look at what we have as far as actual gate drivers on DigiKey. I think they have a whole category for this. Yeah. Power management ICs, and these are transistor gate drivers. And so these are going to look a lot like what we're dealing with, you know, like a little part that just buffers its input, but they're designed for that intense current peak that a MOSFET's going to require. Oh man. I seem to remember having some MOSFET drivers kicking around in some bin of surface mount junk, but I wouldn't actually, like, I might take a very quick look to see if there's something like that handy. These are pretty nice, 10 amp peak current. Let's start to narrow this down. We just want something with a couple of circuits. We only really need one, but some of these might be dual. Want something that can handle N-channel MOSFETs. Something that's in stock, available in small quantities. And make sure it can do low side. And then supply voltage, I'm kind of flexible here. It would be handy if it worked on like 3.3 or 5 volts. 5 volts is more likely to give us better performance just because we can have more voltage swing on the MOSFET, and you know, we can be pulling it up to a higher level even if the threshold is down here so that it crosses into the threshold faster. So let's start out by looking at only things that are like over 2 amps of peak current and see if that limits our choices. And then maybe just look at the cheap ones first. So yeah, these look nice. Non-inverting, 40 volts, 3 amp peak. Wow. I have to imagine it takes some careful design in order to actually achieve 10 amps peak on something like this. Yeah, these part numbers look familiar, the fan series here. Yeah, so this would work at 5 volts. So yeah, they're rating that 11 amp sync is at 12 volts, which is a little higher here than we're dealing with. And like some of this I could get from like a motor driver chip that I might have handy, but I really would not trust a motor driver to have steep edges because that's kind of not entirely what it's designed for. You can see here that this is a lot like, so it starts out with that Schmitt trigger, which we definitely wanted anyway, and then has some other enable logic, and it has a way to turn itself off if the power supply is not up to a sufficient voltage. Then the output stage is just, this is interesting. So it looks like they're using both a MOSFET and a BJT maybe to provide some combination of that like fast initial current, but also kind of a more efficient sustaining current. That's interesting. All right, I'm gonna grab a bin of surface mount junk that I think might have something like this in it just to check. Oh, no, this is great. So Tim in chat has, actually knows power electronics, unlike me, and is giving some pretty good advice. He recommends so either just having, building a kind of a complementary emitter follower output stage on the existing Schmidt trigger buffers I have, like with a 2N4401/4403. He's also recommending a TC44-2X, which sounds like it might be a FET driver chip. Let's see if I have anything handy in here, and then formulate a plan. Oh, I have more inverters. 74 LVC 2G14. I don't think these are faster, but they're in a bigger package. For whatever that means. Like, I don't really care about the SC70 package would be fine to demo. I don't mind the small package. This is my least organized bin of surface mount. I have other ones, but this is the worst. By a very slight margin. They're all pretty bad. Huh. There's some weird stuff in here still. DVI receiver? I don't remember what I thought I was going to use that for. There's just like a 74 HCT 244 hanging out. I don't know what that's for either. Anyway. Now I'm starting to feel like this is Iron Chef. It's like, all I've got is this lab full of crap, and I need to make a fast glitching buffer. Oh, you know, I might even just have... No, I was going to say I might have like fast op amps that would do the job, but this is like probably way faster than the op amps I have on hand could handle. And like an op amp is also way, way overkill for this. It's going to have lots of stuff in it that's just slowing it down. Yeah, just like maybe one other place to check. Now I just get to like look up chips and wonder what they do. 6921. A VFD driver. That's cool. Oh, I definitely got that for a reason, because I have some VFDs that I'm doing a project with, eventually. Yeah. Alright. I have not the hugest array of transistors here. I mean, I think I've got a bunch of NPNs. I think these are all 2N3904s. Oh, is that a 2N3906? Wait, now I'm forgetting which one's the NPN and which one's the PNP. And I mean, I don't know, it's like, part of me wants to like see if I can make this a one-sided driver, like oh, I only really care about the rising edge of the pulse, so I'll just worry about the high side, or I'll just worry about the low side, but I don't actually know which one's going to end up being more important. I mean, it's probably going to be the rising edge, but being able to turn off the MOSFET quickly is probably also important. So, yeah, this might, yeah, I think at this point my best bet might just be with the parts I have now to try using these not the 74 LG, the 7WZ, whatever, the tiny logic chips. I think that might be my best bet right now, but if you have a better suggestion, then I'd love to hear about it. But I might just make this board easy to hack on later if I need to. I mean, I'm sure like if this doesn't work, I'll just order a MOSFET driver and it'll be easy to modify the board. Yeah, the glitches here ideally would be pretty short. The CPU clock I'm working with right now is 30 megahertz, and that's already underclocked quite a bit because this usually runs at 120. And ideally, I would want something where I can glitch, you know, like around half a CPU cycle or so. All right, let's do a little board. Do we feel like KiCad or Eagle today? Let's try KiCad. I think I already have that logic bit that I can pilfer. In fact, it might have even been in some kind of standard library. I forgot whether it was in something that I made or not, but let's take a quick look at that. This is a project from a while ago that I got these buffers for. All right. So I think that was in the, some of that was in the power supply, some of that was in the DMX module. Yeah. So I had stuff like this. Like I was using those to drive signals across a pulse transformer. And that seemed to be pretty fine. I'm going to have that problem where I'm not familiar enough with either Eagle or KiCad that every time I switch back and forth between the two, it's super confusing. Oh, and of course, they both use the same file extension for schematics. There we go. This is the board that I had. I like these boards. That's like an FPGA. It was in a TQFP package. And the SC70, by comparison, where do we have that? I think it's this guy. Yeah, it's under the silk screen there. Oh. Autumn silk, yeah. Cute little thing. All right. Actually, I want to know what library that comes from. Oh, maybe that was actually easier to get on the schematic. I mean, this is just opening the version of it in this local cache. Yeah, all right, I'm not gonna worry about that too much. Let's just make a new board and then get all the parts we need. New project here. There we go, new project. Let's keep it in there for now. All right. Brand new schematic. So we just need a couple of things. And let's see if the library here has any of them and see what we got to end up making. So got some basics. So we don't have the IRF 7807. Let's see what we have that might be similar that we could use as a starting point. In fact, that one might be, let's see if that one's close enough actually. Let's get both of those data sheets and see if they have the same pinout. Because if they have the same pinout, I might not even bother making a new part. I might just change the label on this one. So let's do cute little end channel, the source gate and drain. Looks like the same kind of package. So yeah, I think those are just different voltage ratings of the same part, so I'm just going to use this in the schematic. And what are these versions? Ooh, weird. Alright, let's use this one. And great, there's our transistor. And actually we want, I'm going to give that a label too. Too many different kinds of zooming going on. All right. Hey, Tuco. So we got our transistor. Let's think about connectors here. I think I'm probably just going to want like 0.1 inch spaced headers of various kinds, or like big pads. Hey Tuco, do you want to play fetch? Oh, yeah, this... I don't think I actually need this to be recording right now, but I might as well at least have it be quiet. I will start the screen recorder, though, because that might be useful. Go. Screen recorder. Okay. Screen's recording. Cat wants bolt. Oh yeah, cat wants bolt, and we have a camera. Yeah. All right. So, like, I'm probably just going to, like, honestly, I'm probably going to, like, use foam tape and just attach this board on top of the Ethernet connector, because that's a convenient physical mounting for it. So I think on the input side, I want 0.1-inch headers, because that's actually what I'm going to be plugging in using leads like these. But on the output side, I think I just want some pads on the board that I can solder tiny wires to. Because that's just going to go to points directly on the board under test. And I'm going to want both, like, I think I will want two power supplies here. So one powering the MOSFET driver and one powering the buffer. And I might just get those both from the board under test, because I can get 3.3 volts from its main power rail, and I can get 5 volts from its USB port. So the next big thing I want from the library is the buffer chip that I picked out, slash the one that I had handy. So, oops, that's the PCB. So, yeah. So I'm going to see if I can copy this from that other project that I already made this symbol for. See if I can just import that whole library. Great, so now I can actually go in and just kind of pilfer stuff I was using in that other design. So I've got all this stuff. That's what I want. Cute little hex inversiers. Okay, so I think what I want to do here is to actually just parallel the two on the driving side, but also give me a way to cut that trace if that just turns out to be a terrible idea. Hey Tuco, what do you want, little guy? I am trying to remember my bearings in this program. For example, I am forgetting the basics, like how to move components. I think there is a separate... oh, I guess that works. Okay. So let's place some more of these buffers. Is that... okay, so the way I did this, KiCad actually has a convention of doing this slightly differently, which I don't know if I didn't know that or if I just didn't decide to respect it at the time, but usually these parts that are multi-component like this have a couple of different symbols. They'll have Can I do this? So like here, this is a dual inverter, so I have 2 of these on one chip, and so if I place both of these halves of it, then now I have, you know, if this was, oh, let's actually number these. Yeah. So now it says these are both U1, but this is half of U1, U1A, and the other half U1B. But they both share the same power pins. And so I would just wire up one of these and then mark the other as no connect, which is a little weird. The other approach I've seen in KiCad is that there's a third part of the chip that's just the power pins, and then these 2 don't have the power pins, and then you can kind of choose to place that or not, and if you don't place it, then you kind of get an implied connection to VCC and ground. Hey, little guy. Meow. So let's place a couple more of those. And then on the input side, I don't really want a second buffer on the first input, but I'm just going to leave this with some test points in case I need like a spare for something. Let's maybe try to line these up slightly. Okay, so besides these, we've already got the most important parts. We still need the connectors and some decoupling capacitors. Since, especially for the MOSFET driver, we want a good amount of local capacitance so that it can source a big current pulse into here. Tuco, do you want to play? Oh man, I wonder if it is time for a fetch and coffee break. All right, I'm going to see if I can play fetch with the cat and make coffee at the same time. I will make the camera large so you can watch me fail at that and have some amusement. I also, for this stream, have, oh, actually, yeah, maybe that's the thing I can do now. I got my wireless mic set up. So, this is the microphone you may remember from an earlier episode. It's not amazing. I did some hacks on it to make it less not amazing. But it is wireless, and I think we can get that blended in with this so I can wander around a bit. I was trying to see if I could get audio and video from the machine closet for while we're milling this later. So, check. Hello. There we go. I think the on-off switch is a little touchy, but I think we've got some voice now. So, Cat, you're going to play fetch, and I'm going to make coffee, and maybe we can talk about stuff. Hey, little guy. Where's the bolt? Where's the bolt, little dude? Are you standing near it? Or is it somewhere totally different? Is it over here? There's some way over here. Is this what you wanted? Where's the bolt, little guy? Here's a bolt. How's our camera? Oh, it's all right. Good job, Tuco. You think I can make coffee while throwing this? Who knows? Whoa. Oh, there's... I think there's some other things competing for Tuco's attention now. I mean, he loves the bolt, but sometimes he gets interested in bugs, and I think there's a fly he caught that caught his eye. He doesn't give any interest at all in, like, ants and small stuff like that, but sometimes he likes flies. He also kind of plays sadistically with spiders, which is kind of weird. And, like, I kind of like spiders, and I wouldn't want... You know, I don't like Tuco torturing them, but then again, I don't know. I find it so weird about, like, imposing ethics on animals. Because, you know, he's a carnivore. I don't eat meat, but that doesn't mean I don't let my cat eat meat. You know, I think it's totally natural for him to eat meat, but, you know. Sorry, I probably should have given you some warning and or muted my microphone for that. Tuco was also trying to follow me into the machine closet when I was in there testing the recording this morning. That little cat always wants to hang out. It's pretty nice like that. He will often hang out like in bed next to me. It's really cool waking up next to my favorite cat. Hey Tuco, I know I'm letting you down. Are there any bolts in here I can throw for you? Is it just totally weird for me to be throwing them this direction? Is that not what you want? Maybe that's the problem. Maybe I reversed the polarity, and he doesn't like the polarity to be reversed. It's cold over here because I'm not sitting next to the heater anymore. When I end up in this kind of position where I'm doing some kind of prototyping and I'm just like, I need this thing. Is there any way I can get this thing? Then I go into this like Iron Chef mode. And, you know, and sometimes, of course, it's better just to like take a step back and order exactly the right part. But it's also nice having stuff that is pretty close to the right part on hand most of the time. And, I don't know, I used to like being able to get more useful parts from stuff that I'd salvaged, and I feel like nowadays, you know, it's a lot less common to find anything that's like discrete and usable in electronics you take apart. But I still take a look for, you know, for like stuff like this. There are physical reasons why often, you know, a MOSFET driver is a separate thing, or why the MOSFET itself is a separate thing, and so, you know, can take apart some power electronics and look for interesting goodies. But I don't think I have anything like that handy. I think at one point I had a scrapped UPS board that I was using for parts, but I don't know if I still have that. I feel like life is relatively stable at the moment, which is weird, but for many years I feel like I was just like losing the entire contents of my lab like every few years because I would move or something. And it's not entirely true because there's some things that I have managed to hold on to for a long time, but there's also a lot that's only recently started to be able to be stable. Oh, I'm slightly out of hot water. Tuco, what do you like about that noise? I don't know how, like, I don't know when I started making that clicking noise that he likes, or whether he just doesn't like it, it just gets his attention, but I don't know. Coevolution of behavior with cats and humans, pretty fascinating. Okay, I'm not going to make you all listen to me refill the water dispenser, I just wanted enough for my coffee. Okay, coffee time. And Kat, you are so bored looking. I'm sorry that bolt fetching experience didn't work out quite like we hoped. All right, Took. We're gonna get back to some circuit boards. Oh, now you're coming over here? Well, I'll bring the camera. Alright, I'm going to turn off this headset to save on the interference, since I'm sure it doesn't sound as clear as the other mic. Hey, Tuco. What do you think about buffers, Tuco? I think we could use some connectors and capacitors. Or, as we could call them, the 2 C's. Clearly, we only need 2. None of that C or C++ stuff, just connectors and capacitors. Hey, Tuco, what do you like? Oh, he wants so much attention now that I'm back. Oh, and I didn't mean to turn off the other cameras, sorry. That's what I wanted. I have these scenes that I never use in OBS that are like, full screen, only microscope, no webcams, and I never use them. Because that would involve taking Tuco off the screen, which is almost never what I want. Alright, so on the connector side, I think we want a couple of things. We want some like 0.1 headers, and maybe just some nice big test points that I can solder stuff to reliably. Because the thing about these milled prototype boards is if I'm putting a wire through the board, then the small size pad is not a huge deal because it's got a lot of circuit board material around it to help anchor it. But especially if I'm soldering something like a wire to a small surface mount pad, then if it's small, then there's not much glue holding it down. So I want to make sure I get some more area. So connectors. I think that's the first thing we want. Yeah, that's like the clock input over here. I want to make sure this is something I can, like this looks like a very generic part. I don't know if I actually have a good footprint for this. Let's see if there's a footprint. Huh. Connectors. Okay, pin header straight. I assume the default is 0.1. 3.96 millimeter is not what I want. I think that's what I want, but I'll double check it. So, sure. Oh, and that's so ugly. Let's make some of these things disappear. So let's have this be, not visible. Okay. So we've got glitch input. That's going to be the only thing that I really definitely need headers for. The other things might be better served by test points, but then we might also have headers for just additional connections. Hey, Tuco. Do we want to use that pair? I've never considered using like a pair of test points as one part before, but that's kind of interesting. Huh. Yeah, let's just use these. So before I start placing a bunch of these, let's pick a good footprint. That's not bad. If I don't need a through wire, then they'll be stronger if I don't have one. So let's go for that, and that's huge. That's 5 by 10 millimeters. So that's huge. Fine. Oh, and let's make that disappear again. Okay, and now let's just start kind of placing these and naming them. So, I've got to remember all these key shortcuts. So I want to kind of use these for the otherwise unused stuff, for the power inputs, and for the actual glitch output. Oh, there was a... C for copy. Schematic is probably going to be very bare bones, but it's probably at least worth using power bus symbols though, because otherwise this is going to get really messy. So let's have 3v3 and 5 volts and ground. Alright. Now start naming some of these. So I definitely want the first stage running off of 3.3 volts, since that will give us a much better logic threshold for cleaning up that signal as much as I can. Okay. And these same power buses we'll use for the test points that we actually supply power through and the capacitors. Let's smooth it out. So something kind of like that, but for 5 volts and for the capacitors. Let's pick some capacitors. I think we just want some pretty generic What do I have? Probably 805 surface mount capacitors. So just a little capacitor, unpolarized. In a pretty normal 805. Great. That's nice. KiCad includes some footprints that are slightly lengthened to give you more room for hand soldering surface mounts, which is helpful in this case. Value. Okay, so let's have a couple of those. Let's also have some 1 microfarad. Oh, I had a question in chat about what mouse I'm using, which is an interesting question. This is the Logitech M570. It's a trackball. I actually would not recommend getting one of these particular ones because I think they're kind of insecure. I have been kind of avoiding using it on my main desktop machine. I mean, it's possible this is old and maybe they've updated the firmware, but in general, like the wireless protocol that this emulates doesn't really have any way of only being a mouse. It's always also a keyboard, and so it doesn't have any like real security. So it makes it relatively straightforward for somebody to inject keystrokes into your machine wirelessly. Aside from that, like from an ergonomics perspective, I think I like using the kind of trackball mice for CAD work, especially because it makes it easy to click without moving. I feel like you kind of need different types of mice for different work, ideally. Like I like the trackball for CAD kind of stuff, but for like creative stuff, it's completely useless, or for gaming. Don't do much of that anymore, but would have been a terrible thing to play like a real-time strategy game with, probably. There's all this perfectionism that could go into something that is completely useless, except for this, one test. Try to avoid that. So we got some power, got the inputs, got an extra thing, got a test point. All of that's good. Got some coffee that I should drink instead of spill. Now the next stage is going to be powered off of 5 volts, and I would like to try bridging the two of these together to run them in parallel, which might help or it might not. Like, it would increase the current handling capacity, but I don't know if it would make it faster. So I would like to make it easy to undo that if I want. So if I was doing this in like a more, a design that I intended to be more like long-term, then I would probably go insert like a shorting jumper here. But I think I'm just gonna, I don't even know if I have one of those handy in the library. I mean, we can check. But if there isn't something easy, I might just assume that I'll cut the trace later if I need to. So a jumper normally closed. And then what kind of options do we have for the footprint? Is there no search here? That's annoying. Under oddities. I think this is what I want. This is just something that's going to manufacture as like connected by default, but that I can, like, it'll give me an easy way in the schematic to annotate that if I need, so that in case I change it later, it's more clear. So that's a silly little detail that probably won't end up mattering, but we'll include that anyway. So I'm kind of used to how Eagle doesn't automatically add these junctions. It is nice how many things KiCad will do for you. Alright, I think that's what I want. Then let's have another test point, because can't have too many of these really. Oh, that actually shouldn't have gone there. I don't really like having four-way intersections with the wires. It can be a little more ambiguous and less aesthetic than it needs to be. Alright. Now just some more of these beefy pads for these the outputs here. And this drain can just be, or the source, sorry, can just be ground. I don't need a separate source thing there. But I do want to make sure that I have a dedicated place to solder a really sturdy ground near the MOSFET. I don't know whether the drawing on the schematic symbol means that the PCB symbol itself has these connected in addition to the chip, but might as well be on the safe side. I'm pretty sure that's not how it happens anyway. I think that's everything. So let's move this stuff around a little bit. And annotate the numbers for all these parts so that we can talk about them more easily. Alright. So 2 stages here, some filtering, some output. So I think that's all we need as far as the schematic. Oh, thanks for the note about the camera. I don't really need it right now, but might as well at least clear that message so we can see what's going on. All right, so, that'll be fine. Let's see how far this gets us into having a PCB just with the kind of automatic annotation. That noise means my hot water is ready. Is this it? Oh, my transistor does not have a good footprint. Let's fix that. Oh yeah, this micro 8 is the name of a package, which is not actually what I want. I missed that. I thought that was an SO8, but it's totally not an SO8. That's what we want. Standard SOIC 8 pins. I know it's trying to be helpful, but I really don't want that cluttering up my schematic. Alright. Now let's see if we can convert this to a PCB. Oh, that's not what I'm looking for. That's a bomb generator, like a bill of materials. I think that's the button I wanted. Oh, and this is another one of those Eagle versus KiCad differences that's going to trip me up, because when you do this in Eagle, it kind of automatically places the parts on here, and I seem to remember that there's something you have to do to manually place them in here. Or maybe I just have to manually tell it to synchronize from the schematic. Or load a netlist. I mean, I don't think that was necessary. I think that's done automatically. I mean, I can export a netlist. Maybe this is still necessary. No. What is this thing? PCB new. And then netlist. Oh yeah. Now I remember. Yeah, I think this is necessary, but it's actually like less manual than it seems, because every time you run this, it's like merging the netlist in with your current design. And it's actually, like, I seem to remember this being pretty good. But now it's saying that I don't have footprints for U1 and U2, so let's check those out. Oh, yeah. Maybe I just didn't import those from the other library. So this should be an SC70, which is kind of small. Yeah, SC76. And there's a version with longer pads for hand soldering, which is nice. Let's use that. So let's also just copy that so we can easily apply it to the other one too. Oh. And not make it visible. Okay, new netlist. Generate, replace, and then import again. Yay, I don't think we had any errors that time. So, okay, let's consolidate these slightly. Okay, now let's unconsolidate them. Oh, jeez. Is there a better way to unconsolidate these? I seem to remember having this before and then getting into some kind of Twitter discussion about there being a plugin, or maybe there's being just like a desire for a plugin that kind of scatters your components randomly. I'm curious if anything new like that's been added. I don't know. I think I just need to keep moving these around. Does this move? Oh, local rat's nest. Local rat's nest sounds good. I don't know why I keep getting that though. Like, another thing that seems to be trying to be helpful, but I don't really want that every time I select anything. So I select one thing. Okay, so I have to press M over the blob of things for move, and then select one thing, and then I can move it away. That's how this works. This UI does require some patience, like most engineering software, but it also has some pretty awesome features. Like, maybe we'll get into using the... I mean, this board is so simple, you probably won't notice how awesome the push and shove router is, but that was my favorite feature working on that bigger design that I had open earlier. Because it was super dense for a 2-layer board. Okay, now let's start actually organizing this stuff a bit more. So, keep the friends together. Oh. Also, I don't know if I can fix this mistake here. I just noticed that I named this incorrectly. I think I have to fix that here and then and then do the netlist export again. Because I want this to be, instead of test point, I want this to be 5 volt supply. But then I want to actually change this, the reference back to something else. Okay. Annotated. So now they all have numbers again. And let's do the netlist. So that's just taking the schematic and generating a file that doesn't necessarily include the kind of pretty details of like what gets actually placed where, but it includes like electrically what's connected together. And then that's very similar to the thing we were doing in the FPGA where we got that .blif file that gave us kind of a net list of electrically where all the gates are connected in the FPGA. Why is this not connected to anything? Do I have to... re-import that and then update the rat's nest. That 3v out is not connected to anything, it seems. Maybe it's just not showing up because they're... Huh. I don't know why this wouldn't be showing up. I'm concerned because this part doesn't have any of these air wires that specify like where the connections that still need to be made go, which tells me that maybe this isn't wired correctly in the schematic. So this is W5, 3V out. It's just acting like this isn't a real connection. Maybe that isn't a real connection. Maybe I have to place a doodad there. Maybe that's what I needed. Alright, let's try that again. Export the netlist. Maybe whatever I was saying earlier about KiCad doing that automatically was a total lie, and I lied to everyone. That's better. So now this is telling me, hey, yo, this needs to be connected to something before you're done. Alright, now we can just kind of collate these together a little bit, make things a little tidy. Do we have Tuco? Oh, Tuco. You are totally in camera range. I'm just a terrible camera operator. You're such a kitty, Tuco. Alright, I'm going to try to keep the screen zoomed out, but then zoom in KiCad, because I keep getting the two both zoomed, and then it's like doing audio mixing then, and it's like all the levels are wrong. It's like one of your mixers is way too high and the other one's way too low. Alright, so I think the best way to lay this out is to first just start with the glitch output and then just start building backwards from there. So I want these to be pretty near the edge of the circuit board. And this is probably going to be a two-layer board, so it'll probably be the thing where we have to mill both sides and use DIY vias, which isn't bad. They're just, the vias are annoying, so we want to minimize them, and if we can get away with it, we can make this a one-layer board, but I suspect it'll need 2 layers. So there's our little MOSFET. What else do we need? So right on the input to the MOSFET should be the buffer we have driving it, which is this one. No, it's not that one. That is, oh, it's U2. No, U1 is driving the MOSFET, so U1 should be closest to it. Sometimes it's easier to look at the schematic than try to follow the air wires. So those are grounds. Okay, and these little links, the ones that are acting as cuttable jumpers, like we want to keep these pretty close, but also give them enough space so that I can actually cut them easily without messing up other things, and then even use the 2 pads as like sites for other reworks if I need to later. Let's get some of this stuff out of the way. Yeah, I mean, I'm pretty sure that the power for this buffer is going to have to come from the backside. see how that works. Something like that. Now, we also want there's the 5 volts version of the glitch signal, which is also the MOSFET gate. So that would be a good thing to just stick over here. Yeah. Something like that. Imagining this thing being kind of like a little rectangle. And it can, it can like stick out over the edge as long as this part is something I can like stick down near the area I'm interested in. Let's also just rotate these. These pads are kind of huge. And I don't mind them being huge. The hugeness might come in handy, but I think that might be a better way of using the hugeness. Uh, 3 volt out. Something like that. Yeah. Oh, that's a good question. There's a question in chat from Wildmania that why not use 0 ohm resistors instead of cuttable traces? Because I don't have any surface mount 0 ohm resistors handy. That's the only reason. If I was doing this for production, I would definitely use either solder bridges or cuttable or 0 ohm resistors. Adafruit lately for this has been using these solder bridges where they make two pads that have solder mask openings close together, and then put a little bit of paste there so the solder paste reflows and bridges them. And then you can easily cut it just using a soldering iron, which is super convenient. So yeah, the other reason I'm using these kind of longer pads is that if I do end up wanting to cut these, it's probably because I want to modify this somehow, and so that might give me a little more room to work. Let's see. Let's see where we want the next buffer. Something roughly like that. So this is also going to be inverted. So like the 5 volt version of this signal is inverted relative to the input, but then it gets inverted again by the next couple of inverters. So the whole thing ends up being non-inverted, but this intermediate output will be inverted. So we also need some supplies. Man, these pads are enormous. Maybe I do want to use something smaller. Geez, it's like 5 by 10 millimeters. Well, I mean, let's go ahead and arrange things and see how bad it is. So, glitch input. We want the 5 volt supply to be reasonably close to the MOSFET, or sorry, to the buffer. Oh, this one. Huh. I have 2 5 volt supply test points. I think I might have labeled one of those wrong. There is. Oh, maybe one of these doesn't. They both seem to be in the net list. Interesting. I mean, the one labeled W10 is the correct one. I think the other one is left over. Maybe I can safely delete it. That's fine. 5-volt supply. Oh yeah, this is also the pads where we have extra things. Yeah, these pads are way too big. Let's change this. This is like ridiculous clown shoe surface mount pads. So, what else do we have to choose from? I mean, all the holes designed for soldering wires, or there's one pad that I see that's designed for soldering wires, and it's huge. I think maybe what I want is like a test point hole, but I mean, I could also like edit this footprint. I just kind of wanted to see if there's something standard, since I thought there was a library that had just some standard, like, individual pads like this. Measurement points, maybe? Ooh, this looks right. Huh. I wonder what they mean by big here. I don't know what that scale is. Like, is that a millimeter? If that's a millimeter, maybe that is big. But let's try that out. I'm sure that's smaller than what I'm using right now. This is good. We'll bulk change them in a sec. Alright, what did I just change? Okay, 3V out is the one that I just modified. That doesn't look right. Did I miss an error message? It looks like it gave me a warning here instead of... Oh, I have to actually tell it to change the footprints. That's right. And if I wanted it... So the reason it didn't delete the other one automatically is also I didn't tell it to. So let's just have it be a little bit more rampaging with our PCB. That is much better. That is so much better. Yeah, let's just change them all to that size. Oh, I forget whether... I think there is a way to do a bulk change like that. I'm also forgetting off the top of my head how to do that bulk change, so it might be faster just to edit each of these. I'm also noticing this individual little junction that got here for some reason. Delete that. Yeah, okay. So I think I can just edit each of these. Yeah, especially some of these I might even want to make smaller, like these extra in and extra out. I'm going to make those the small ones because these are unlikely to be useful. Oh, and the outputs here, the glitch port, it's tempting to make those smaller, or to leave those as giant, but I think I'm still going to change those to the big measurement point here. Because that wire pad, that 5 by 10 millimeters or whatever, is just way too big. So let's see how much that helped. See if I missed any. Okay, Okay, I missed the 5V out, but the rest seem fine. Okay, that looks more manageable. Uh-huh. This is definitely going to be a double-sided board. Oh, something like that. We also need room for the capacitors, for sure. Let's get some capacitors. Even if I use the backside for some wiring, I don't really want to put components on the backside because then it's just harder to assemble. I also want to resist the temptation a little bit to pack everything in as close as possible because, you know, it'll make this thing easier to deal with if it's small because then it won't kind of obscure as much else that's going on here. But if I make it too small, it's just going to be annoying to deal with. Oops. Didn't mean to separate that from its home. Huh. Alright, so a couple of these. Making a giant circuit here. It's going to be huge. If that word even still has an H in it. Yeah, this is looking better. Just a little thing. And, I mean, I also want a pretty sturdy connection between these grounds, so I want to make sure that I don't separate them too much when I'm wiring this up on the backside. But let's do that. This. That is a little overlappy. Something like that. port here. I think that's pretty much what I want. Just a little thing. We can make it slightly littler. Let's actually maybe double up on, or like add some more test points here, because I think I'm going to want another way to monitor the glitch input besides just that one input. So maybe some more like these. Copy that. I'll stick it over here. Okay, it automatically joined at that time. I must have just done something wrong once. Let's just do that. I'll call it input. Update the PCB. Oh, that's right, I need to annotate. When it still has these question marks where the parts don't have a name, it can't generate a netlist because all the parts have to have names in the netlist file. Alright, now we can open again. And I think it's not going to make changes to my existing stuff this time. Yay, input. Yeah, so I mean, some of this feels a little clunky when I first get started on any project in KiCad, but then kind of reaches this point where it just feels fun. It feels like you just get into the zone. And that's nice. All right. I think I'm just going to go with that. Let's draw a border around it and start trying to route it. We want a line. Yeah, I don't want to put it on a copper layer. I wanted that on the dimension layer. Oh, maybe edge cuts? I think that's what that's called here. Okay, I think that's what I wanted. Yeah, it's not super pretty, but it'll do. Let's, I was going to say let's move it to 0, 0, but I don't think that's necessarily a thing as much as it was in Eagle. All right. Just looking at chat, and there's another question about what this is even for. I'll try to summarize it. The large picture here is a setup for getting the firmware off of microcontrollers that otherwise don't have a way of giving it to you. So really similar to this experiment that I documented in an earlier video and a POC or GTFO article for USB. So I was using a voltage glitch to get the processor to incorrectly run part of the USB stack such that it would give me a big dump of the code memory instead of just giving me the device descriptor, which was a small part of the code memory. So I'm trying to do something very similar on a different processor. And so part of what I'm dealing with is just adjusting the setup to handle all the different kind of electrical conditions in that processor. And so a lot of things are faster, and there's a voltage regulator that's providing a lot more of a kind of low impedance regulated like stable power source that I have to fight against in order to cause the power to drop. So this is a circuit that I can put physically very close to the chip that I'm glitching. It'll have the MOSFET that actually drains the power out of the chip very momentarily. And it has some buffers that I can use to, first of all, condition the signal coming from the chip whisperer board, and then to try to drive the MOSFET fast enough. And I don't know for sure that this is going to be fast enough, but this is something that I have handy and it might work, so I'm giving it a shot. So I think the next step is just to do the routing, which hopefully is fast. And hopefully I can remember how to do it. Is this for routing? I think this is for routing. Yeah, let's use wider tracks. Ooh, and let's not put them way out in the middle of nowhere. We need to set up our design rules. I think there's a menu somewhere that has, like, I think it saves the track widths per circuit board. So there might be something in the design rules for this board I have to set up with track rules. 2 copper layers. Yeah. That's what I want, I think. So we have net classes. Default. Okay, this is in millimeters, 0.25 millimeters. Let's do like 0.8 millimeters maybe. Bigger vias. Let's see, I want something, so I would like to be able to drill my vias with a 1/64th inch end mill. So that would be 25.4 millimeters. Oops, not that big a number. So that's 0.396 millimeters is kind of the minimum that I want to deal with. So 0.4 is fine. And so I think the default vias are all right. I just want to make the tracks a little bigger, and then until I have a reason not to. So that looks like that. And in fact, I think I will have a reason to make them a little smaller, because I should just set the track width to whatever the width of this SC70 pad is. Let's see if I can, oops. Let's see if I can actually determine that from in here easily. Yeah, 0.398 millimeters is the width. So let's have a track width that's a little less than that, maybe. .35. Cool. That seems better. Huh. I think it's updating the rat's nest, but it's a little hard to tell. But yeah, I'm just slightly used to the kind of visual feedback Eagle gives, I guess. Oh, and I don't want that little stub. Yeah, I guess the mistake I made was canceling that. Oh, wait. I think I pressed escape and then that canceled the entire track. Oh well, that wasn't quite what I wanted, but let's try that again. So, oh, it's probably going to work out best. Like, I think every time I route these chips, I just end up having to take ground and 5-volt out to vias pretty much right away. So maybe let's do that and see how, whoa. Just trying to switch layers. How do I switch layers? Yeah, that was weird. So I think I canceled that wire, but it wasn't, and it didn't actually disappear until after I redrew the screen, which is a little weird. So yeah, maybe another little quirk here. Anyway, I'm going to try to lay a trace and remember how to switch layers during the trace so that I can make a via. Just want to start with this. What is the keyboard shortcut for this one anyway? X for track. So track, and then click that. And then I think I want to click, end it. So maybe double click. And then switch layers. Is that going to make a via? I don't know if that's going to make a via. I don't think that is. Yeah. Let's, maybe this is probably really easy. Maybe I'll just ask the internet and it'll have a quick key shortcut. KiCad route, switch layers via V key. Gotcha. That's easy. So X. Oh, not that layer. Okay, and V does toggle layers when you're not in track mode, which is also nice. So lay a track. Let's go there. Press V to toggle layers. Now I've got a via. And I'm actually going to have most of the back be a ground plane, but so even though this ground track on the back won't actually show up in the final design because it'll be subsumed by a pore, it'll actually be helpful to just have that in the design to just make sure that that path stays clear and I don't inadvertently cut that path and separate my grounds. So I think I'm just going to go all the way up here and then put in another via and start connecting these on the front side. I feel bad not putting these capacitors closer to the buffer, but oh wait, I'm routing this the wrong way. This is the 3.3 volt buffer, that's the 5 volt buffer. So this needs to go over there. These capacitors are probably close enough. Yeah, it's tempting to have the output go through a via instead, but I don't know. It probably doesn't matter. I think putting the 5 volts through a via there is as good as anything. vias are a little close together, but I think it'll be fine. I mean, I wouldn't worry about that at all for machine assembly. It's just one of those things that makes hand assembly slightly more annoying, but I think it's more important to keep the vias away from this chip with some clearance, because that's one of the things that'll make soldering this chip more annoying. So I think that actually wants to go this way. Oops. Keep pressing undo when something is like, when I have that like oh no reflex, but then it undoes slightly too much. There we go. Via. Let's distribute this power a little bit. Oh yeah, the other thing, I was about to run a trace on the top side here, but it's also for hand assembly a little easier for inputs like this if they can run on the bottom side, if you're planning on soldering the connector on the top side at least. So in this case, like this would be a ludicrous thing to do on a like on a board that you're manufacturing professionally, but on a prototype board, taking this out on the bottom layer and then having it go through a via to the top layer is actually kind of convenient. So bottom layer, via, and then top layer. These vias look pretty small, but I think they'll be fine. Like I could make them much bigger potentially. Let's try making them a little bigger. Because I just worry that these vias, again, like they'd be fine in a professionally made board, but they look like they'll be fragile if you're milling them. So that drill was alright. Make this maybe slightly bigger. Maybe 44 and like 7.5. Huh. I don't know if it updated all the vias or not. Looks like it made the hole bigger, but... Oh, maybe it did make the copper bigger too. Yeah, it looks like it did. Nice. Maybe I have to tell it to update stuff. I don't know how to get it to update these, but when it decides to update them, they seem to be fine. Huh. Select. Yeah, that's weird. The vias over there seem to have gotten upgraded automatically, but this one didn't. Well, a bunch of these didn't. Interesting. $75 and 44. That is just strange that some of them are updated and some of them aren't. I don't know what the difference is here. Does it change if I move the via around? No. If I edit the via? Oh wait, something I did caused it to update that via. I don't know what, but now it thinks the via is the right diameter. Okay. It feels like there's some kind of cache in here that isn't getting updated or something. It's tempting to just close and open the program, but I only have a couple more vias, and this seems to be somewhat reliable. Okay, let's go back to routing. Oh, this one, the one that seemed so small to begin with. Yes, that's a little nicer. Back to the ground. So I think here I want to make sure that this ground has a good path around this way. So even though there's a flood fill, like I think this is where I actually want that to definitely connect at the moment. So in this input, be better if I start those traces from the chip so that they line up perfectly with the chip pads. What? That's a weird one. Maybe I click once there. I'm trying to fix that internal kind of elbow position so that that doesn't overlap when I do that. If I click once, nothing happens noticeably. If I double click, then that seems right, but then as soon as I move, it disappears. So that doesn't seem right. What if I do that more piecewise? No. No? Really? Okay, I'm gonna reopen this program. This is, I think something is working against me right now, and I want to see if it's transient or not. Oh, that's the footprint editor. That's the PCB editor. Okay. Let's see if I can make this happen. It keeps disappearing, that trace. And this via is still undersized. No longer. How about this one? This is another one of those things where like I could go directly down, but without a solder mask, it's actually kind of nice not to have pads that are shaped like that. It's easier if all the pins come out parallel to the, or all the traces come out parallel to the pins. Is that why this was disappearing? Was it like failing DRC right there? What if I do that? Oh, that's better. Okay, I was just steering it too close to that via. Yay, that's better. Come back. Okay, I think that's real. It does still need to connect over here, and I think these vias are a little close. Well, I think this is... Okay, this might be an opportunity to use the push and shove router, because I want to make a little more space here without violating any of my rules. Let's remember how to do that. If I remember right, there's something weird that you have to do to enable push and shove mode. Let's Google that really quickly. that's right. I do have to be using OpenGL mode, which I don't know if it's set right now. Oh, I guess it wasn't, because that looks very different. All right. Now I've got to remind myself how to use this. Set up your clearance, which is good. OpenGL mode. Laying out tracks. It looks like I just have to, oh, here we go. Router behavior, press E and select, and change the routing options. Press E in what context? Huh. Oh, while a context menu while in track mode. Okay, so it's like press X and then E, and then you get here, shove mode. So now when I try to move something and it's not allowed, it'll try to make things right. So I can grab this via, control click it, and then press G to grab it. Ooh. Yeah, see that? It's a little hard to see what's going on because my grid is so big. Let's make my grid littler. Oh, grids. Grid. Let's have a half-sized grid. So now if I do that same thing, control click to select the net, then G to grab the via. So I can kind of move it around, it's kind of trying, but up here, oh yeah, that's interesting. I guess I wasn't grabbing the via, I guess I was grabbing part of the track, which wasn't what I wanted. I seem to have created a little track extension. Let's delete that / walk it back. Control click G. No, maybe I just have to delete this section. Deleting this track section is a thing I could do by pressing something. I guess I just had to clarify my selection and then remove one of them. Okay, that could have been smoother. But I think right now if I wanted to, for example, try that again, I think I want an even smaller grid, and then I think I can try moving the via without making quite so much of a mess. So let's switch to maybe a 2 mil. All right, so selecting the via this time. Now G. Is that doing its thing? Oh, I have to be in routing mode, so press X to get in routing mode. Then select that. Then G. I'm still moving the trace though, not the via. Maybe the via is not as movable as I would like. Let's try moving something like this. Moving it back. I think I might be doing part of this wrong. I think this is actually drawing a new wire and not doing a push. That is weird. It's still in shove mode. I think the operation I want is called an interactive drag. Well, whoa. See, that's definitely the place and route, or the push and shove router doing its thing. So like as I'm putting in a new track, it's automatically making room for it. But it's also capable of doing this, just moving stuff around that's already there. I'm just somehow failing to do that. Let's see if that helps. If I can just use the regular move command now. Oh, I think that's helping. I've still got this super tiny grid. Let's have a less tiny grid then. Let's go back to 5 mils. Oops, did I just set that to 0.05? No, okay. So now if I grab this, come on. No. Okay, I guess grabbing it with the G key doesn't work, but just dragging it with the mouse does. So this is the thing that really makes all of this worthwhile. You can just kind of push stuff around and it'll kind of make room. So I can kind of put that as close as I feel like. Same with this. And then it feels like there's a little bit of a snap happening, like when I fully straighten this wire, it does seem to be like removing that node pretty well. Anyway, I think I've got enough room now. Maybe a little too much room. Oh no. Let me undo that? Yeah. Alright, anyway. Let's turn the grid up. And just run some more traces. I think I'm done fighting with this. Yeah, I spoke too soon. I mean, the ideal trace shape would be a little different, but this is probably fine. That'll still be pretty easy to solder. So now that that's connected, actually, it'll maintain the clearance we want. We could try just moving this via where we want it. So we want this via to have a little more clearance, and then try to get these to come out straight. Yeah, that's not quite as pretty, but much more functional than what I had before. There we go. That's not bad. Alright, and I don't want this like too consolidated there because this is a thing that I might modify. So I want that running that way. Let's run some more of these traces. And that was definitely a placeholder. Let's move these a bit. Yeah, that's starting to be fun. Let's not put that necessarily closer to the via than it really needs to be. Fine. And then these. So these, I'm probably going to have, like I don't know, the SO8s are so big, I'm not even really going to worry about how I run these pads to make it easier to solder or not, because like this is totally fine. And I might even put little polygons there just to kind of give a big copper fill, but I don't think it's, yeah, that'll be fine. So I also want to have a pretty good connection to this ground. So the most important, good solid low impedance path here is just across this glitch port, because I'm going to try to wire that in at an appropriate place. But I do just kind of want all the grounds on here connected together pretty well, so I'm going to try to use a ground plane in the back to do that. But I can also get a direct ground path through here, so I'm going to make sure to keep that open with a trace, even if I polygon fill it later. Do we have anything else? Oops, that's not what I wanted. Is this the rat's nest? Oh, I guess it's already updated. 3 unconnected down there. Oh, where are you? I think these were unconnected. Oh yeah, these need to be connected explicitly. Okay, now it's telling me 0 unconnected nets. If you look way down here, 0. So let's put some fills on the front and the back. I think this is what I want. Polygon. So front copper, ground. And we could change some of this if we needed to, but I'm going to make the pad connection solid just because the thermal reliefs are just going to be kind of annoying on a milled board. Oh, I think I double-clicked too soon. That is what I wanted. Oops, and I forgot ground. Alright. Oops. Let's just like draw a polygon and then make it the polygon we want. There's something weird about the scrolling direction, like somehow, it's like sometimes scrolling out actually scrolls in instead, which is really weird. Anyway, I've placed a polygon. Oh, there it is. I guess I have to click on it to get it to redraw. But you can see, because, okay, fucking zoom out. Oh, wow, that is one of the more annoying bugs I've seen. Like if you zoom out too quickly, then it zooms in instead, or something like that. Anyway, we can see what the ground is doing. Some of these have been kind of subsumed by the ground fill, but then you can also see how it's kind of created these little islands. And those are connected together. I could put another polygon over here, just to give the MOSFET a little bit more copper to hang on to. I might do that, just like, I doubt it's important, but might as well give it a little bit more heatsink / a low impedance connection to something. So this will be connected to that net, so we haven't given it a specific name, but just this one that we can see in this label that's really tiny on the stream, but it says net Q1 pad 5, so just an automatically generated name. Still no thermal reliefs, because don't want that. Thermal reliefs will give you little gaps around pads, kind of between them and the fill, which is helpful because then it provides more of a thermal disconnect between the pad and the fill to make them easier to hand solder. But it also just makes them weaker and is kind of annoying for milling. So we also want this to be higher priority so that it, in this local area, kind of supersedes the ground fill. I think I need to reload the ground fill. Yeah, there we go. Cool. So now this is just a polygon. Oh, and here, that's interesting. This ground trace has kind of created some little islands here, where I guess the algorithm that's doing this fill doesn't know that this area should be ground. Let's see if I can just wiggle these tracks out of the way to make this a little cleaner looking. Moving these traces that are in the ground fill to try to get the best clearance. And now just recalculate these fills. Okay. So now that's our ground with like a pretty decent area here. I might make this polygon a little bit smaller just to make this path where the ground gets through somewhat beefier. Sure. That's kind of nice. Oh, zoom out. Okay. So I got a polygon for that output. Now let's take a look at the bottom side of this board. So I want to temporarily turn off the top side and just look at the bottom. Is there an easy way to turn off just the front components? Maybe not. Silk screen, paste, fab markings. That's fine. We can get a somewhat clearer picture now at least. So we've got a couple of these, but it looks like it'll be all right at kind of keeping the ground pretty contiguous. Let's also go ahead and just put some vias on like all these grounds just to help them tie directly to the ground plane. I mean, I know I said minimize the vias for hand soldering, but these will be important-ish, and you know, we could always leave them out if we really don't want to solder them, but having the grounds tied together is a pretty worthwhile goal. So we've got those two, and then this one, and that one's already going to be tied. I mean, it would be on a plated through board, but let's just add another via here for our non-plated board. Over here, maybe. Alright, that should be alright. Let's go back to the back side. And put in a polygon. Backside connected to ground, no thermal relief. actually try to draw the polygon correctly the first time. Alright, so I think that's what we got. We've got a nice solid ground in the back with a few vias, and then a couple of these little traces. So this one was 5 volts for the output, for the MOSFET driver slash inverter that I'm using there. And then that, I think, was just bringing an input signal over. Oh, that's 3v3. So yeah, another nice thing I like about KiCad, which I think EagleCAD is doing now also, but you can zoom in and the net names are written on all the traces. Zoom out. Okay. So that's our board. We can do a quick design rule check to see if it notices anything wrong, which only really is meaningful to the extent that your design rules are meaningful, but we're mostly using defaults, but I think these are plenty within the capabilities of the mill here. All right, so I think that board design is pretty much ready to start cutting. I am going to take a brief break to refill my water and stuff, and then check chat, and then we will get this started cutting. How's your morning, Tuco? Oh, there's oh, yeah, there's a bunch of, yeah, there probably are some things that I could be doing much better with KiCad. And, definitely appreciate any hints if there's an easy way of getting those through the void. Also, a comment about how the annular ring on the vias are pretty little, and I think I agree. Like it's probably fine, but a bigger one would certainly help. Let's see if there's just an easy way of changing all of those. Brr. Maybe I should get more coffee instead of more water. Is that what I wanted? I think that's what I wanted. That's still kind of small, but... Can we go to 0.9? Yeah, that's fine. Now it would just be great to have a way of doing that for all the vias. Let's see if there's anything easy about that. Oh, what was that called? there's a good way of just changing all of these. It might be faster just to do it manually because there aren't that many, but I think in the past I've done stuff like this by just doing a search and replace in the KiCad data file. So these might need some pushing. That one maybe? Do we have them all? I think we got them. Maybe this one? Yeah. Alright, those look a little more sturdy. Let's do another DRC just in case I mess something up. Alright. I think the next step here is to make some Gerbers and load this into the mill. So, Gerber time. I think we want fabrication outputs. I forget how this part works too. It's not in plot, is it? Yeah, plot. Gerber. And output directory. So we need copper layers. Not going to bother with silkscreen. We just need copper and drill. And we should make sure that if possible, the outlines are on all the layers, I think. That might be default. Oh, here we go, yeah. Turn that off to not exclude the PCB edge layer from the other layers. And then drill marks, yeah. So I think we just have to do the drills on the Gerbers separately. Plot, and then generate drill file. And I think the defaults, those seem fine. Okay. So, I don't have an easy way of doing screen capture from the machine in the milling closet. So I think the first thing I'm going to do is kind of demo the setup on this machine, but then basically just do the same thing in the closet, but be filming the mill. I know you used to be able to save setups in their software, but I don't know if you can still do that. I think it might just be like you have to load the Gerbers and then just generate all the, or set up all the parameters like right when you're about to use it, which is slightly annoying. And so this milling software is kind of nice in that it can directly open a bunch of formats that aren't typically, milling only. So it knows how to do basic SVGs, I think, or at least it used to. And it can't do a lot with SVGs, so I often use like vcarve instead. But in addition to actually taking G-code that's already kind of baked into the format the machine needs, this can take circuit boards either directly in EagleCAD format or in Gerber, and it'll actually figure out how to generate the G-code itself. And it's pretty good at it. So this has presets for the circuit board material. Once we're actually in there, I'm going to measure the material and be a little bit more careful about dimensions. But let's just do a quick check to see how this looks. Glitch adapter. So I think here, if you just open up any of these Gerber files, then it'll give you a window to do the rest of the process. Yeah. So there's some kind of rough, if you haven't come across Gerber files before, it's a really, really old school, very specific vector graphics format that's used for creating the mask images for exposing circuit boards during manufacture. So basically each of these files is just a vector image with dimensions and all that. And so we've got one file for the top copper, one file for the bottom copper, and then another file, which I guess it's already picked up, for the drilling machine. And in a regular PCB house, you know, the two copper layers would go to photo imaging machines, and the drill file would go to a numerical controlled machining setup like this. But in this case, we're machining all of it. All right, there's our board. All right, so right now you can see it's got those red outlines indicating stuff that it wants to machine, but it doesn't have a small enough tool for. Because it defaults to a 64th inch tool. If I pick out it defaults to a 32nd inch tool. If I pick out the 1/64th inch tool instead, then that is weird. I think that's interesting. It has, I think it's confused about where the board outline is, and it's also putting board outlines around this. Yeah, that is weird. Let's not have it do that. So one thing that might be helpful is to actually just take a look at the Gerber files that are generated. Because especially if we start seeing weird things in the manufacturing stage, it's nice to look at, look at the data and see on which side the problem might be. So there's a Gerber viewer in KiCad. I guess it's just not in my path. But yeah, Gerb view. So let's just open up these files. Let's get the front and the back copper. So that looks all right. We have two. Oh. Whoa, that's weird. Okay, this shouldn't have. Oh, okay, that's just a feature of. I thought this was like text or something, but I think this is just saying. I think that's the diameter. So I think that's just the Gerber viewer annotating this. Anyway, this back layer looks all right. This outer line is the routing boundary for the board, which is something I specifically told KiCad to put there, since I think this tool likes having that. On the other side, I have the same boundary, but then different copper. So yeah, I think this is just annotating, because this format doesn't have like a lot of the primitives you would expect a vector graphics tool to have. It's really just about drawing lines with rounded ends, because originally this was controlling like a photo plotter machine that used a little aperture on an XY table to draw. Anyway, those files look fine. Let's see if I just tell it not to do the outline yet. Let's also see what happens if I just tell it to use the front copper for now, since that's all I'm milling. Okay, front copper. Okay. Oh, I might just do the top and bottom separately. That might just be a small software glitch. So if I switch the tool to 1/64th inch, now that's small enough to get in all of the vias. And it can route out a lot of these traces but I still need something smaller to get in here. So I could switch to, well, not switch to, but in addition to that larger tool, I could use something small like a 1/100th inch. But actually in this case, even that isn't quite small enough because this is a little bit under 10 mil. So in that event, I actually want to use one of these pointed engraving tools. So what I've been doing here is using one of these like kind of pointy tipped engraving tools such that you can make pretty much any size opening depending on how far into the material you plunge. You'll notice that's still failing to get these little areas, and that's because in addition to using the engraving tool, I also have to tell it that that it's okay to not go very deep right here, to take just like a very shallow cut. And that's something that you have to kind of tune, because if it's too shallow, then you won't clear through the copper. So I've actually got a notepad in my machine closet that has all the settings that I use for the stock that I have handy. Because what I did is I tuned this trace depth. So like by default, it's trying to cut 0.2 millimeters into the copper, which is more than it really needs to. Like that's pretty conservative. So for example, if I change this down, let's say 0.04, now you can see the rendering here showing it not even like totally clearing through the copper, but it's like that might just be an artifact of the resolution of this rendering. But you can tune this so that really you can make this as big as you can to kind of give you the easiest machining job. If this is really small and you're taking away just a tiny bit of material, then you have to get everything dialed in just right so that you're taking away the right tiny bit of material, and you want, like you can't accommodate as much variation in the thickness of the material, for example. So I want this to be as big as it can be without failing to machine some areas. And it's complaining about these vias right now, but that's fine. I'll add a second tool to do the vias. Right now I just want the deepest trace depth that still allows me to clear these areas right there. So that's too much. Okay, looks like I can do 0.15 millimeters, which is actually pretty deep still. The default is 0.2. And so on the simulation, you can kind of see what it's doing, where it goes in between here with an angled tool. And then I'm also going to have this 64th inch tool to cut out the holes. So that's pretty much what this will actually look like. And then I think I'll use a 32nd inch tool to cut the outlines. So that's pretty much what this will be. And then for the other side, I'll do the same thing, but if you flip this, then the mill actually has this nice bracket system where you can easily flip the board over while keeping it referenced. So, like you can reference this corner to this edge of the alignment bracket and then flip it, and then reference it to the other edge of the alignment bracket. And the software is already calibrated where those two corners are, so it can flip it all in software. All right, I think that's everything for this particular location. I think I'm going to put on the wireless headset and go into the closet and do some milling from there. Catching up on chat very slightly. All right, cool. I'm going to go into the other room, and you should be able to see me. It won't be quite as good as these cameras, but that's the 3D printer with a thing that I was printing yesterday that's like an air-powered top that I think Tuco might enjoy. And that's the mill. And headset would be helpful. Tuco might try to come in the closet with me once he sees where I'm going. check. Alright, I think I'm mobile now. Alright, Tuco, I'm going in the closet. It is a closet, it's by a little... not by much. This would be easier if that file was somewhere I could... If that my directions on that computer also. Alright, let's move that intro. Is nice. That was nice and fast. We've got our glitch adapter, one box machine. We've got our robot. Hello, robot. Alright, first thing, tutorial. Alright, I think this is my bag of things. Maybe you get this through the mill camera. Take off the window. The circuit board blanks from the machine company. It's like 25. And these are, you know, they seem pretty good quality. I think they're 1 ounce copper F1, which is the easy cutting material, and the F4 fiber. Just to make sure I have it. 1.64 millimeters. Material. Yes, I still had this set up for Pyrolux, so I have my set at 0.06 millimeters. Just not for this. So 1.62. I would like to have a better screen in here. I was thinking VNC. This is a pretty slow Windows 10 machine in here. Let's see my work. It also might just be way too CPU for the scene that's already having trouble. I'm just measuring board. I don't necessarily need good X and Y inches, but it'll at least kind of help. So that's like 120 width. Just run like a long HDMI cable. This is a monitor. Have to. Well, maybe there's another output on this computer. 126 millimeters by 1 millimeters by 1.62 meters. And I've already got the bracket in the mill. That should be located. Double-sided. Tell it to place the board at the left bracket, and so I'm going to be lining it up right there. And now I'm going to files that we just generated. And starting with the front copper. Okay. You know, I typoed or like pressed an other plan earlier that gave me a separate use an outline Gerber. Instead of merging it in, I might export that as a separate file. But for now, I think this is fine. I think it was just that I picked the bottom copper as the outline layer, so it was trying to use that as a path. Yeah, if I use the software properly, it's working much better. Some of this through the other camera because it's slightly visible, but it's not good. I'm mostly just in defaults here, so I put in the circuit board size, and I imported the reverse default layers from the edge. Make sure it's layers from both edges and not just one. I think that might have been so I had from my experiments. Tuco's out. I hear you, little guy. You want to come in? You want to come in, Tuke? He kind of likes here sometimes. A lot of stuff to climb on in the closet. So, milling tools. So, I think if that I have, so like you can kind of control about this and set up milling operations with a particular tool. You can also give it up to 3 tools and just tell it to do everything. I think I'm going to do that because I think that's going to give me the results I want. So I'm going to give it an 80-degree engraving tool for most of the circuit traces, and a 164, and then second inch for just all the, big cutting the thing out. All right. There are other things that sometimes I customize when cutting holes. So like, one thing I like to do is cut the vias from both sides. So I'll give the board a bit of a Z offset and cut the holes so that they don't go all the way through from both sides. Really clean hole, no kind of wound. I actually want to cut the outline out until I've done both sides. So here's what I'm going to do. Actually, I'll be more of a control freak. I'll trace this with just the 80-degree tool. See how that goes. And then, assuming I think the next step will be to do the vias so that they don't burst. Okay, so I've just traced the tops with the 80 degree engraving. Now I've got those red lines indicating that the stuff in between the those white mill out. So I need to change this depth. Default of 0.2 millimeters to the value that would work earlier, 0.15 millimeters. Okay. Now we've got a preview that looks like it's showing the kind of outer engraving stuff and all the traces that work fine. So software is all set. Just put some stock in here and change when we actually start milling. Get that in loading position, and to hold it down, so I've got this board, and then I've got this needle that I'm using to hold it base. And it's like decided to take it much stronger and more uniform. So I'm going to put some of it like right under where we're milling and a little bit elsewhere. Kind of like that. It's easy to curl a little bit when off, so when I the tacking and use that to get me. Just don't do that. For something like this, super table down, it's like plain double-sided tape works. I think I just find that this, this is a little going to be jacked morses, and it just seems to work so reliably that I've used most of my milling lately. So just lining it up, pressing down, and the software is I can't actually tell it I want the wing, which is how I get the tool change on until it goes on. So I've got to put the windows on and then tell it will involve taking the window back off. So start milling, and it's moving to the tool change. So the one in right now I think is 164. In fact, that is I'll leave a nice sharp 164 thing for the power. I'm going to try to ginger. Oh, it doesn't get stuck all it, and it's like moved. Alright, put the 60 those. I agree. This is for a bunch of circuit boards, but it seems like these last a while. And the little thing is just on that focus it's actually clear the chip so it can get pretty effectively. So you can just make yourself out of it. You may have design files for it. Alright, next thing I can do is do its little touch off to get a Z location. But it won't actually hit. It's getting noisy and but that might but it's weird. I don't know how bold, but you can kind of see the computer screen here. It's showing the plan. Looks nice momentarily. Oh, is there something back? How's this looks? It looks silly. All right, let's come back. Why do we not have TucoCam? Around. What's up, Tuco? Why don't we have TucoCam anymore? Whoa. Alright, are we back? I don't know why we don't have TucoCam. Why no TucoCam? Huh. I think maybe I have to restart Tuco cam. There we go. Sorry about the stream dropout. Hopefully I can get the rest of this machining on there. It is an IP camera. I think my local network has plenty of bandwidth, so I wouldn't expect that to be causing a problem with the stream, but it certainly could be like a CPU problem on OBS. When I came back out here, OBS was still reporting 30 frames a second, but the kilobits per second on the stream was down from its usual like 1500 to like 40, so I don't know what was up with that, but let's see if we can keep this up. There's a little bit more machining here. Oh yeah, a little occasional glitching on OBS. Oh, are we still getting... Check. Yeah, still got audio. Cool. All right. Holy Jesus. Yeah, that was definitely way too deep. I think there's something wrong here. So I think I might have just measured something wrong or set something wrong because the oh, you know what? I think I forgot to add the thickness of the tape. I think that's what happened. So this is very not dialed in. I don't know how easy this is to see on the camera. I really should have like a handheld camera for this also. That would be really nice. But I'm going to cut the next one. Like, I'm not even going to move the move the board. I'm just going to move the layout over a little bit. Guess I'll also take this opportunity to clean out the mills very slightly. I always like to have the area where it does the touchdown clean because I don't know how likely this is to happen, but I always imagine it failing to detect the collision because of some dirt particle or something, and then ending up messing up the tip slightly. I'm just going to blow that a little bit. Alright, so I think there are a couple of tweakables here. So the trace depth, I don't really want to change that because that mostly affects the geometry of how it's cutting. What I really want to change is actually the Z height of the circuit board. So, and I could change that either by changing the placement Z or the thickness Z. And the difference is really just depending on, like in this case, since we're engraving the top of the board, it doesn't really matter. But later, since we'll be doing holes, it might be useful to set the Z offset to the thickness of the tape. So I'm just going to approximate that with calipers, but try to be on the large side, and then we can step it down until we start getting a good engraving. Because right now we just plunged too deep in the material, and so all the traces are too thick. Or all the gaps that it etched, rather, are too thick. And you can also avoid having to do this particular kind of calibration if you use the flat end mills, because then the depth isn't so much of an issue. And so that would almost be a better solution for this board, because most of it doesn't need the small tool. But since I'm using those SC70 footprint buffers that have, kind of a small spacing, like I could modify those footprints to be barely within the capabilities of the 100th inch end mill, but this is just an alternative that doesn't involve modifying the design. So just measuring the tape with calipers, which isn't the best way to measure tape, but it seems to be somewhere between 0.12 and like 0.18 millimeters, depending on how much pressure I put on it. So let's start with a Z offset of like 0.25, which should be way too much, but let's just get an idea of how too much it is. An entire 1/4 millimeter. All right. So I've got my whole 1/4 millimeter, and I also want to move the design right, which will also move it closer to the camera. And this would be nice if I could remember how wide my design was, so I would know how far to move it. But I could also just move it like roughly half the width of this. 60 millimeters. All right. So still same deal, 80-degree engraving tool, no tool change. I'm using a different part of the stock, and this might not even touch the surface. It might just be a complete air pass. If so, I'll just move it in a little closer, and we won't have caused any damage that we can't just plunge forward through. All right, so just wants the window back on, and then this is willing to let us make another mistake. All right, milling. Well, it's not a total air pass. This might be all right, actually. Like, I thought this was going to be an air pass, but it might just be fine. One way that we would know if it is too far away is if it doesn't completely cut through the copper in some places. But so far, it looks like it's all the way through. I'm going to check on the stream from out here for a sec. Hopefully OBS has not already crashed again. We have 1800 kilobits. Oh, there's a little confusion about the fisheye. It's a combination of a lens and a software trick. The lens is just a plain old cheap fisheye, but then I also masked the image into a circle so that I could do this compositing. And so that's just like an image mask in OBS that's done after the capture. It's not like warping it or anything. It's just making some of the pixels transparent. Well, that's not bad. Just looking out here, like, it was hard to tell what the audio lag is on the, or the lag is, compared to between like the audio or kind of like real-timey stuff out here versus the camera in the machine closet. But it seems like it's pretty real-time. Hey, Tuco. Good job, Tuco. Tuco's kind of into lasers, but he's much more into these bolts. I've had this work in progress, like automatic bolt throwing thing for a little while that I should take another attempt at. I just temporarily I was about to say abandoned, but I kind of backburnered that project for a while because it seemed like I was spending time working on that when I could have just been playing with Tuco. All right, let's see if that cut all the traces through. that's looking good. Yeah, let me see. Can I take a photo of that? I don't have a great little portable camera thing, but I'm just going to take a photo on my phone and then show you on the other camera. I mean, I guess I could also post it on Twitter, since I have Twitter out, since it was for some reason open. Hey, Tuco, do you have a bolt for me? Wow, here it is. Anyway, I'm trying to tweet this too, but there we go. I think my Twitter client is hung, but that's fine. Let's go back in the machine closet and do some more machine. Okay, so we've got all the traces. I think the next thing to do then is remember this Z offset, but then set an even larger one and use the 64th inch to mill out the vias from this side. So I'm going to go from that 1/4 inch up to something that gets me a little bit farther than through half the board, but not quite through the other side. So maybe we'll set this to like 0.85 millimeters instead of 0.25. And then I'm going to not mill the traces, but only mill the holes. And select a 1/64th inch flat end mill. So this will do a little bit of air pass like above the board, but then it'll have the benefit of not actually breaking through the other side, and it'll give us a clearer, it'll give us a slightly less grody surface to attach the via wires to. So again, I've got to put the window on, and then tell it to mill, and then it'll ask for a tool change. If I restart the Twitter client, it'll let me post that photo. All right. If anybody's curious to see that fuller resolution photo, I just posted it on the Twitters @ScanLime. There's always a little bit of swarf that gets stuck in the threads for this. I should remember to clean that out. All right. Next tool is the 1/64th. Oh, there's another reason I don't like milling all the way through with the 1/64th, is that this particular tool actually has a really short cutting length. So if I plunge too deep into the material, I end up kind of rubbing the shoulders of the end mill up against it, which is not so great. It just ends up putting extra force on stuff and making kind of a frictiony little skid mark instead of a hole. Alright, while these holes mill, I'm going to do a quick tea and restroom break, so I'll be right back. Oh, maybe I also need the cat to have lunch. You want to eat something, Tuka? Alright, maybe it's a cat food and coffee break. Got some microphonery on again. Yeah, actually we need to feed the cat. Tuco is in a hungry kind of mood. He really loves the salmon chunky stuff that, of course, seems super gross to me, but he's into it. And then tea would have been a good idea, except actually coffee sounds awesome. Good old afternoon coffee. Full of beans and water. It sounds like the machine stopped. Maybe I can see what the machine needs and then make my coffee. So if this worked out, I think it's time to flip the board over. Let's take a closer look. That's looking good. Got a bunch of cute little vias. So let's just flip this board now. Get some leverage under the tape, prise it off. Alright, let's try to just do the same kind of thing with pretty much the same parameters and the same materials, but on the other side. So, same tape. Kind of focus on putting it on the back side of the board itself. Of course, if I'm going to do that trick with the knife to get the tape backing off, it helps to use a really sharp knife and not a really dull knife. Really dull knives are terrible. I should really change that blade. There's nothing you want to use a really dull knife for. except maybe if you don't want a knife. If what you're looking for is actually like a wheel and a knife are very different from each other. Alright, so I've got the tape on the side that we just milled, and I'm going to tell the software that I'm flipping it over, that was the alignment. I'm going to tell the software I'm flipping it over. Now it's aligned to the right side. So align it to the bracket and kind of push it up against the bracket and down onto the build plate. So just like before, I'm going to start with, well, actually I was going to say before I was going to start with the traces, but actually since it doesn't seem to really matter whether you do the traces or the vias first, since I've already got the mill set up for vias with the right Z height and everything and the right tool, I might just mill the vias since I don't think I actually have to change any of the settings other than just pressing go and flipping it over. So let's do that. Let's do the vias. This is just holes again. Holes only, no traces, no outline, 1/64 inch with a Z offset of like 0.25, oh no, 0.85 millimeters, that's right. 0.25 is what I was using for traces, 0.85 is what I'm using for vias right now. Alright, I'm going to finish making coffee. I've got one of those Aperture Laboratories mugs. It's pretty awesome. I highly recommend him. I'm not a huge gamer, but I think there's something about Valve that I ended up liking, even when I was pretty new to gaming and didn't game much myself. Like, I kind of enjoyed looking at the bits of engine technology that you could kind of get at through the mod system and all that. And then I think I got more into kind of Half-Life 2 engine games, not necessarily because I was playing them, but because I was debugging them at work at the time, trying to make them work on a graphics driver. But I liked Portal. I still have not actually played through any of the Half-Life games entirely. Like, I think I started playing Half-Life 2 and started playing Half-Life, but didn't really get very far in either of them before getting bored. But Portal I liked a lot. I played both of the Portal games. Oh, hot water. So milling the vias on the back side should take pretty much the same amount of time as milling them on the front side. And then it's just traces on the back side, which should be pretty quick since there aren't very many of those. And then cut the board out, and then we're ready to assemble it. So not a lot of steps there. I heard that mill stop. I relatively recently moved the machines, like the 3D printers and the mill, into that closet, but it's a huge improvement. Like, I mean, the mill jobs usually aren't so long that the noise gets annoying, but the 3D printer jobs, like, not as loud, but much longer. And so I got pretty used to having to like sleep in the loft upstairs while the 3D printer was down here in the shop chugging away. And with it doing the same in the closet, I pretty much don't hear it, which is really nice. All right, let's save this coffee for later. And let's do the next milling step. I still have some good memories of good bugs I found while working on like graphics drivers that were supposed to run like regular games. All the classic things like, oh, you have some very subtle bug in your shader translator, and so now all the vertex animation is messed up and the characters look all spidery and weird. Yeah, lots of that kind of stuff. Alright, traces with an 80-degree engraving tool. It's still got the trace depth of 0.15 set, which is nice. And I'm going to set the thickness back to 0.25, which seemed like it would be large and I would need to decrease it, but now it just seems like I kind of happened to guess about right, which is nice. Alright, so 0.25. I think that's good. I'll just hit go and then it'll ask me for another tool change. I thought I'd cleaned it out, but there's still a little bit of a hitch right here in the... Like there's a bit of plastic or something that I have to work the thread over to get it out, which is not really good. All right. This one should be really quick, but my coffee is out here. There's a bit of discussion in the chat on milling machines and yeah, the different. I almost got a Shapeoko, and I was going to go in on it with a friend at the time, but then like a bunch of social craziness happened, and I ended up like having to like disappear from that group of people pretty quickly. And so I'd actually already helped pay for this Shapeoko. We were going to go in on like three parts, and because we were roommates, that was going to be fine, right? But we weren't roommates for that long. So it's one of the many reasons it's kind of nice having my own tools. You know, like my interests last a lot longer than my jobs or my, you know, living situations usually do. So it's nice to have stuff I can take with me most of the time. Oh, does the mic and the coffee sound bad? Sorry. I'll stop doing that. I actually have mic'd Tuco in the past. That was another good suggestion. I don't have a good way of keeping him mic'd, but I was trying to get some samples of him for just like a music project a while ago, and I had a little wired lavalier mic that I would clip to his collar and then just follow him around. Which worked all right after I got him to the point where he wasn't just immediately tackling the wire every opportunity he got. All right, this is looking really good. I know the details are a little hard to see right now with the camera in the mill, but we'll get this thing over to the microscope soon enough. The only step that's left is to just cut this thing out. So I am now going to tell it the placement is back at 0 because we want it to cut all the way down to the bed. And I'm going to tell it to only cut the outline. And it doesn't matter whether I'm cutting that from the top or the bottom side, since it's pretty easy to clean up that edge. And then with the tools, just to have something that's pretty fast but doesn't necessarily take up too much material, I'll use a 1/32 inch, since the 1/32 and everything smaller than that are pretty sturdy and the mill can move them pretty quickly. It's the 1/64 and smaller where they start getting like super delicate. Alright, so that's all there is. Put the window on, do the tool change. Alright, 1/32 inch. This one has a little bit of swarf on the end, but mostly clean. Alright, last tool change. And there it is. Let's do a little bit of clean out. I don't really have enough electricity in the closet to run the vacuum cleaner and the air compressor at the same time, so I just do one then the other. Pressurize the pump and then turn that off and then use the vacuum. All right, now this, oops, nice resilient camera. So this big piece goes in my scrap bin of stuff to use for other boards. And then this little piece, we will take that over to the microscope and take a look at it. I don't want to take the tape with me though. The tape is staying in the trash pile here. Alright, so yeah, see leftover material and the little one. Okay, done with this setup for a little while. Alright, we have some circuit board success. Let's take a closer look. Also going to take off this headset because I think I'm done with this and it's slightly annoying. Yeah, the Othermill is more expensive than some other options for sure. I think part of the reason I ended up with it is that it was kind of designed by someone I knew, and so I had a little bit of the like, oh, my friend designed this kind of hype, and I do really like the machine. I might not have quite spent quite as much money on it if I didn't kind of already know a little bit about what I was getting into. Yeah, it is an expensive mill, and there are, I'm sure, cheaper ways to DIY a mill that can give you similar results. But it is pretty nice just how much accuracy you get in that package. Oh, sorry, Tuco. I was trying to get the microscope set up. You know, all these things change. I'm not really friends with that person anymore, and they don't even work for Othermill anymore. But, oh, hey, Tuco. I had that set just right, and then you stepped on it. There we go. All right. But yeah, I also really like how, you know, it's not just a circuit board mill. I can use this to, I mean, I've been making little doodads out of Corian and HDPE on here. And so there's definitely some overlap with what you could do with, you know, other kinds of small fabrication tools. Like certainly some overlap between this and like a laser cutter. So these are the little ones that I was working on. These are the SC70 pads. I need to clear a little bit of space here. There's too much of a mess right in front of the microscope. Oh man, I was almost about to let Tuco type in a whole bunch of strange things into chat too. I hate when the test setups get so big that I'm not really sure how to move them. Often when that happens, I find myself attaching stuff to a larger board that I can move around. Don't necessarily want to attach all this stuff together though, because like, I mean the chip whisperer I want to keep easy to reconnect to other stuff, at the very least. So. Alright. That Ethernet is kind of in the way. Maybe I'll just unplug all of this and plug it in later. So we'll take the USBs out, and then we have Ethernet and more USB. Yeah. So that's the experiment right now. I can move this slightly. Okay, experiment will come back soon. For now, just soldering. And I have one more stick vise. Okay. So usually there's a little bit of cleanup I would do even before bringing it to the desk, but I want to show you just exactly how this comes out of the machine. All right. It's a little too much light. Yeah. So there are definitely some areas where, like it looks like it takes one pass on either side of where the original, like where the Gerber file says the gap should be. And so it looks like I'm getting, I'm going to use the knife to point. So you can see there's kind of like a left track here where it did one pass, and then there's a right track and a tiny little sliver of copper in between them, which is a little concerning because these are the kind of little slivers of copper that might wander away and turn into conductive debris. But in general, this is pretty nice. Even these little vias with the little annular rings came out pretty cleanly. Got little bits of copper that are still left there that aren't electrically important unless they decide to mechanically migrate. Some of these, like this little thread here, it's not quite clear whether that's copper or not. It might not be. So some of these, like if I just lightly like brush or sand the board, then some of these little hangers on will go away. But you can't be too aggressive with that, or you might damage stuff like these vias. You know, this is also going to be a little delicate, but not so much so. What else? Just a little bit of stuff in these holes, but I'm sure that'll just, yeah, that just pushes right out. You can kind of see how these were milled. It leaves like a little top hat shape in because it does a spiral along the edges. So then the other thing I would usually clean up with just more of like a larger scale tool is just the edges. Because like I was saying before, like with the vias, I wanted to be kind of careful to like not poke through and make this nasty edge. Whereas on the sides, it's not a big deal because you can just easily sand those away. So I'm just gonna grab a sanding sponge and make quick work of these edges. I have this silly problem I was having where the last sanding sponge I grabbed for a job like this was soaked with cutting oil because it was like next to my drill press when the oil fell over. That was not so fun. I managed to get the thing I was cleaning pretty clean, but then I had to clean the oil off of it. So I'm going to try to give it a bit of a chamfer on the edges here. Yeah. I guess holding it at an angle and then rubbing it is probably the most effective thing. Let's get at least a little bit of that on film, even if this isn't interesting, really. So I think I'm also going to try just very lightly sanding the top. I don't know if this actually does more good than harm, but it might remove some of the small bits of hanging on material. Yeah, I probably should have like rounded the corners. Somebody in chat had that suggestion, but it takes like an extra couple of clicks in the software, and it's actually, if I'm just making one board, it's faster to round it with a sponge than with the software. It's just the way these things often work. Alright, so now this is maybe more like what I would want to start soldering. The edges are pretty clean, and the surface is kind of scratched up like that, which will actually make it a little bit easier to solder, even if it doesn't look quite as nice. And I think we've made sure there aren't like giant pieces of conductive debris hanging on that we could easily knock off. So I think this is just ready to have some stuff soldered to it. So I'm going to turn on the microscope recorder. Oh, did you go sit down in the counter or in the chair over here? Alright, microscope recorder is recording. Cat camera is cat cameraing. Oh yeah, I know the microscope isn't frontmost, but there's a separate recorder that's just getting the high quality stream for my video editing later, and that's what I was turning on. I will swap that over in just a sec. Alright. Cool. Alright, let's just put on that, I guess we could start with the hardest parts and do these little SC70 doodads first. It's often a good idea to start with the small ones. So I'm going to double check. I think pin 1 was top left for both of these. this. Top left is pin 1. Okay, just little buffers. It'd be so easy to lose these all. Like that. It's definitely into the territory where the parts are so small that the markings aren't especially useful. But it at least has a pin 1 dot and kind of tells you what chip it is. Like, you have to kind of know what series it is already for this to make any sense. Alright, so I think the easiest way to get this tacked down is just going to be to tin one of the pads first, and then we'll just hand solder all the pads once that's aligned. It's not a lot of solder, but it should be enough to tack it down at least. Whoops. Maybe I should be using my less bad tweezers. My whole hierarchy of tweezers, I do have tweezers that are less bad than those. Let's see how it looks from the other side. Not quite centered. I have the microscope tilted to get a little more perspective, but it does kind of distort the perspective a little. Like, it lets you see stuff that otherwise might be hidden, but it's hard to center things on that axis. Come on, little guy. I might actually need my even less bad tweezers. Of course, the shaking hand isn't helping either. That's nice. I'm happy with that. Oh, let's have this microscope be tilted less. This is too much. Kinda. I think that's an improvement. Yeah, that looks much better. All right, next, let's do the same thing. Tack down one of these pins. I think there's quite enough flux on that side. I'm also realizing that in another one of these boards that I had been doing on camera, partly because I needed it and partly for demo, I was making a face dancer, and that has a bunch of vias under the chips. So to make that work, I had to be careful to do this in a different order, where I would have had to do all the vias first and then sand them flat and then put the chips on. But since I'm not putting any vias under chips this time, thankfully, then I can do the vias anytime I want. I'm not limited to doing them before the chips go on. But yeah, normally I might do the vias before getting to this stage, but those little guys look fine. Cute little SC70s. So maybe now let's do the via wires. I think with that, I think 26 gauge is going to fit through these holes if I remember right. Oh yeah, too much coffee. Well, usually, I don't know, I think there's a fine balance to be struck between number of coffees and number of joints, and then somewhere in the middle is the right soldering experience. There's a little bit more closeness when I insert that. It's one downside of having the two via drills meet in the middle like this, is that sometimes you've got to kind of force the wires through the vias a tiny bit. Last time I did this, I managed to get into some kind of flow where I was putting these in pretty quickly, but it took a little bit of practice to get to that point. And it helps if I have a long enough wire to start with that I can just cut off a little bit and keep going. Okay, so my current strategy is to strip off a bit of this wire, hold it near the end with the pliers, and then shove it in a via, and then trim it, and then repeat. Oops, and then I keep messing it up like that. Let's try that again. I've also been meaning to try these little via rivets that have been suggested to me by a couple of people. Yeah, for vias this size, the rivets would certainly need to be little, but I'm not against little things for sure. I mean, the main thing I would want is, like, depending on the circumstance, like for this board, I would just want something that works fast, because this is just a quick experiment, and whatever I'm doing, like, I just want to fail fast at whatever it is, so I know what to do next. Whereas if I was prototyping something that I then intended to make a bunch of, my goals would be, instead of just to make something work as quickly as possible, my goal would be to have something which is fast, but also very close to the final manufacturing plan, so that there's as much opportunity as possible to test that ahead of time. also maybe one of those things where the microscope view is perhaps slowing me down slightly. I'm noticing it's a lot easier to align these things when I'm not looking through the microscope. But it doesn't really look like anything on video if I don't have it on the microscope camera. Oops. And if I bend it like that, I've just got to cut off the messed up edge. I could use smaller wire, probably. I think part of the problem is that the vias aren't necessarily entirely drilled through, and so I'm actually kind of maybe pushing through a little bit of the FR1 with the wire, which has, I guess, the side effect of like holding the wire in pretty sturdy, since there's a little opening that's just the right size for it. Oops. And something like that. Yeah, like I'm trying to push that in further, but it's actually already in plenty, so I'm just going to cut that off and move on. If the wire is too small, I've had this other problem, though. This other problem where, I mean, I guess this is only an issue if I'm trying to make very flat vias, but if I'm trying to make a very flat via, then there isn't necessarily enough solder to make a good fillet if the wire is too small. Let's find something slightly more convenient. I think that's all the easy ones on this side. Let's just turn this over. Come on. Oh, hey, Tuco. I feel you on my elbow. Okay, that's another wire that had already made it through, but was being annoying anyway. This also seems like something where I can imagine some kind of tool that would make this much faster, where it's just like kind of a screwdriver shaped thing that has a wire sticking out of it that you can then like press into a hole with a decent amount of force. Ooh, is that one also stuck? No, that one did not make it through. Practice, practice. Each one gets easier until you die. That's better. 2 more. Yeah, I messed that one up. Switch sides. Last wire. We can do it. One more wire. vise look good on both sides, so now it just needs some solder. Oh, that was already on. Oh, and Tuco is back in this spot. Alrighty, cool. Do some wire now. I really enjoy the kind of work where, you know, you can concentrate on something and get really deep inside of it. And that happens with software, but I feel like it's a little harder to get that with like putting together hardware, because so much of it is more like integrating components together. And so I think part of what I like about prototyping is that feeling where you get to get really deep inside the hardware, because you've got a good excuse to be working on all the layers of the stack. I mean, prototyping and reverse engineering both. But it also reminds me of just how, I don't know what this is like in other countries, but like in the US, it feels like we have this really weird relationship with manufacturing, where like there's, to some extent, we really like, you know, having things, but we don't necessarily like making them. And so there's all this kind of cultural infrastructure here that makes it seem like, oh, if you're making things, that must mean you're just like lower class, you know, because really classy people are all about controlling people and collecting rent and doing all these other things that are like more economically efficient than, you know, actually making stuff. Let's cut some of these. Oops. More cutting. Wires get in the way, and then it's good to take a break and cut them. Always one at a time. be all of them on this side. It'll be easier to see once I cut these. All right, other side. Okay, let's do these. And then I think that's the entire bottom side. Well, except for soldering this little header on. Sometimes your joint's so ugly, but just a little bit of flux, and it'll be right again. Oh, that's much better. Problem you can avoid by making sure to heat the joint before adding solder. Cute little puddles. I do really like the way that the copper wets with the solder when you first contact it. It's this really interesting texture as it kind of crawls across the surface that I'm not really used to. It doesn't quite, like liquid metal coating another metal, and the way it just kind of hangs out there without any beading, like with this very flat interface. It's super weird looking and I like it. The microscope, it's pretty hard to see if that's actually joining to the wire really well. Like some of this is not like waiting for it to have a good appearance. Instead, it's just like giving it enough heat to where it seems like it must have worked. But I'll get a better view once I trim the wire. Which I kind of need to do anyway because things are getting in the way. Seems fine. Oh, that's a good piece of advice. I just noticed from chat a suggestion that fluxing the wire before inserting it can help a lot. And I've never tried that. That sounds like a great idea, though. I can imagine having I don't know if I have one of these here, but you can get like a little, it looks like a container of lip balm, like a little cylinder of flux paste, and I can imagine just dipping the wire in that really gingerly before inserting it. I've got some other kinds of flux around here. Like I think I've got just like liquid flux in a bottle that I use with my, this is not going well, that I use with, what is it called? Solder pot, when I am soldering lots of things. And you can just dip the wires in flux and then dip them in solder. Speaking of flux, it's so weird like how long it took me between like starting to solder and really getting an appreciation for flux. Because I think it's easy not to really get that when you're taught, only a certain kind of soldering using, kind of traditional soldering with through-hole components and flux core wire and all that. And when you start coloring outside the lines using like solder paste and solder pots and adding your own flux, then you can start to see how important it actually is. Alright. I think that's all good for the back side. A little bit more trimming maybe. Alright. Just making sure these aren't too spiky. Alright. Back to the other side. Well, let's take another look at this. Make sure nothing's out of place. Here's something. Inductive debris. The best kind of debris, except totally not. One thing that stands out at me is like this area looks like it could be a short, but I think I took a look at that from the other side and it was fine. Yeah, that just looked suspicious because of the angle. I think those are all fine. Okay. I think the next piece I feel like adding is the two-position header. Let's get some garden variety snappable header. Can't really have these things hold themselves in with only 2 pins, so I'll use a little bit of this blue tack putty. Alright, so that does it for the back side. That is all we needed. So back to the top. Just got some surface mount stuff left. Let's do the MOSFET next. So all we've got left is capacitors, MOSFET, and installation. So MOSFET goes over here. You can only really see one of its pads because the rest of them are connected together. The little MOSFET gate, and then multiple pins for the source and the drain. And pin 1 in the top left for this one also. Again, the tweezers in the microscope want to occupy the same space. I might have to take a stream break soon to get some lunch. Lunch is good stuff. Dot top left. I'm just going to anchor it on the bottom right and adjust it with the tweezers. MOSFET. This MOSFET and the LDO regulator are going to have epic battles every couple of milliseconds. Alrighty. I think that's, oh, the capacitors still. Need some capacitors. So those go, where are those? Those go on the top. Oh, that's right. So since I turned off thermal pads, or thermal vias, or sorry, thermal separation for these pads, these are the pads for those capacitors ground. A little hard to see, but you go there, 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 and there. And then even though that looks like it goes, that's a component. Those are just our 2 test points for the unused buffer. So I think I was going to populate those with 0.1 and 1 microfarad to start with. Here's 1. Somewhere I'm sure I have a giant roll of 0.1s. Yes. Big roll of 0.1s. sprinkles. You gotta have sprinkles. You gotta put these everywhere. I'll come back to that. Okay. Two 0.1s and two 1 microfarad. Not really any science behind these values, it just is a good starting point. Okay, I think that's pretty much it. MOSFET, output pads, places to put some extra stuff if I need it, and more test points, and then up here, that test point, and this middle area, which doesn't have a thermal via, or thermal separation. That's where I hook up the power. So I think this is probably a good stopping point for this stream, since I think I need to take a break and get some food and generally do some self-care stuff before I do the next step in this. But I think the next step is to wire this up in the target and to see how much this improves our ability to deliver good tiny glitches that are actually going all the way down to 0 volts, hopefully. And so, for some context here, if you missed the beginning of the stream, this goes in a setup that I've been working on to try to extract firmware from a device by injecting a fault while its HTTP server is trying to read some data from the file system portion of its flash memory. And the goal is to try to get that to instead read the entire firmware image, or at least usefully sized pieces of it. And so a lot of the rest of the setup is, getting a good timing reference, and I'm underclocking the device along with its Ethernet peer in order to make the thing a little easier so that I'm dealing with 30 megahertz instead of 120. But yeah, this still seemed to be a useful addition to try to get a sort of stronger negative pulse going on the core voltage. There we go. That's the view I wanted. It's so tricky to find the right light angle that lets you see the surface engraving on these parts. So this is an SO8 package, and that's, like, if you're doing any surface mount, it's probably a common package, because a lot of things, it's like kind of the biggest commonly available surface mount package. But then these guys are SC70-6, so 6-pin, and it's kind of a smaller than SO23 transistor standard, but certainly not the smallest. And then maybe get a quick view of that on the DSLR also. There we go. Pads for soldering stuff, some buffers, big transistor. Pretty clean. And so the idea behind the different connectors here is that I would kind of implant this pretty much permanently in the target device and wire this to appropriate places on its circuit board. And then this is just sort of a place where I'd plug in an input clock from the chip whisperer, or an input glitch signal from the chip whisperer, or from anything else that can generate 3.3 volt logic, like an FPGA board. All right, looks like Tuco's semi-awake, but mostly in a napping mood. I love you, cat. Well, thanks everyone for joining me for this little circuit board fab stream. Made a little board all the way from scratch, just from an idea to a physical thing. And certainly not much of a thing, but it's exactly what I needed for the testing I plan to do today. So it's a good skill to have, and I hope more people can have access to this kind of prototyping. All right, have a good day, everyone. I will see you on the rest of the internet and on the next stream.